All right, this is part 3 of section 2.7. Now we're talking about compound inequalities. So a compound inequality includes two inequalities in one statement. So there's two ways of solving inequalities. You can separate them into two different inequalities and just solve each one of them by themselves, or you can leave it as it is and apply the operations on both sides at the same time. A compound equality with an AND represents an intersection. So within the two inequalities, where those two intersect, what you're going to use is the symbol. It looks like an upside down U, but that is referring to the intersection of those two inequalities. Now, a compound inequality with an OR represents a union. So you're going to put the two inequalities, solutions for the inequalities, together. And that's represented by a, looks like a U here, the symbol U. But this is representing a union. Okay? So this is what an inequality will look like. You've got two inequalities, and they don't have to be the exact same. They can be different from each other. But what I like to do is I like to keep it intact and just work this inequality as one whole inequality. So 4 less than 2x minus 8 less than or equal to 10. So what I'm going to do is I'm going to add 8 to every part. So we get 12 over here, 2x, 18 over here. And then I'm going to divide everybody by a positive 2, so nothing flips. So I get 6, I get x, and I get 9. Okay, so what we're saying is x is going between these two numbers, 6 and 9. It's not including the 6, but it is including the 9. So on our number line, if we have 0 right here, I'll write 6 right here and 9 right here. Okay, I'm going to have an open circle for 6, but I'll have a closed circle for 9. And then I'm just going to draw a line between the two. And that represents x is going between 6 and 9, but it's not including 6, but it is including 9. Now you could also write it like this. You can have a parentheses on 6, a bracket on 9, and then go between the two. For set Biller notation, x such as, actually, get rid of that, 6 less than x less than or equal to 9. Or you can write 6 starts at 6, not including 6, and goes up to 9, but it does include 9. Okay, so let's look at this one. 3x less than 4 minus 5x less than 5 plus 3x. And I'm going to subtract 4. Actually, what I'm going to do for this one, because I've got x's everywhere, I have them over here and here and here. This one will be easier if we separate them out. Now, this one right here is an AND combination or inequality, as well as this one over here. This one is also an AND inequality. So what I'm going to do is 3x less than 4 minus 5x and 4 minus 5x less than 5 plus 3x. Okay, so I'm going to, we'll subtract 5x over here. So that gives negative 2x less than 4. Divide by a negative 2. And x is greater than negative 2. Okay, and we will subtract 3x from both sides. So I get 4 minus 8x less than 5. Subtract our 4. So we got negative 8x less than, that's going to be 1. Divide by negative 8. X is greater than negative 1/8. And it looks like I have a mistake over here. This should be a positive Okay, so let me redo this one. Okay, so that's going to be 8x less than 4 divided by 8. Okay, so x is less than, looks like 1/2. Okay, so we said an and inequality is talking about an intersection. So where they intersect or they lap over. Okay, so if I get my graph up here, we got two numbers. We've got, I'll go ahead and write 0 on here. So we got 0, we've got 1/2, and we've got -1/8. Of course, this is not drawn to scale. For this first one right here, the arrow is pointing this direction. Okay, so, and it's going to have an open circle, and I'm going to go this direction with it. Okay, for this one, we have an open circle at 1/8, and it's pointing this direction, so I will go this direction. Okay, where we have both of the two colors there, that's my intersection, so that's going to be my answer. Now notice I've got open circle right here, they both intersect right here, and then an open circle right here. So that's my answer. So let me get rid of everything. So my final answer is open circle, and between the two. Now we could have combined these two as well. If I put an X and then less than and then less than, just like I had it set up over here. Okay, well, so this is X less than 1/2. So X less than 1/2. Notice that the smaller portion of the inequalities face an X. Okay, the bigger quantity of the inequality is facing X. Okay, bigger portion of the inequality is facing X. So this would be -1/8. So 8 goes between -1/8 and 1/2. And since I have both less thans and not less than and equal to, so the less than, I'm just going to have an open circle. Okay, so set builder notation. X such that X is between -1/8 and 1/2. And then for your interval notation, starts at -1/8, not including it, goes up to 1/2, and it doesn't include 1/2 either. Okay, so now let's look at an OR inequality. So we'll just separate, they're already separated, so we'll just solve them like they are. Okay, so I'm going to add 5 to both sides. So that gives me -6 divided by 2. So x is less than -3. Over here, I'm going to subtract 1. So 5x greater than or equal to 5 divided by 5. So x is greater than or equal to 1. Okay, now an OR inequality is talking about a union. So what we're going to do is we're going to put these together. So on my number line, I'll have 0, I'll have 1, and I'll have -3. Okay, for the -3, I'll have an open circle. Notice this is pointing this direction, so I will also point that direction for my arrow. Okay, on the 1, I'm going to have a closed circle. And notice how it is pointing this direction, so I will go this direction with my arrow. Okay, so the combination of those two, that is your answer for the graph. If we were to put this in set builder notation, x such that x is less than -3 or x is greater than or equal to 1. And then for the interval notation, okay, if we take this first one here, this one right here, because it's starting out at -infinity. Okay, it starts out at -infinity. goes up to -3, doesn't include 3. Now because this is an OR inequality, we'll use this symbol U to represent a union. So I will use U. And then this one right here starts at 1 and it also includes 1. So bracket 1 goes out to positive infinity and then a parentheses. Okay, let's look at another one. Okay, so we got 2x plus 7 less than 13, or -3x minus 2 less than or equal to 10. I'm going to subtract 7 from both sides. So that'll give me 6. Divide by 2 on both sides. Okay, so that'll give me x less than 6. Over here, I'm going to add 2 to both sides, so -3x less than or equal to 12. Divide by a -3. So x is now greater than or equal to, that would be -4. Okay, now on our number line, I'll put 0 here, 6 over here, -4 over here. If we look at this one first, I'm going to have an open circle. And then I'm going to point my arrow this direction. Okay, for this one, I'm going to have a closed circle on -4. It's pointing this direction, so I will also point that direction. Okay, now remember, OR is a union. So it's taking both of the solutions of these inequalities and putting them together. Kind of like we did with this one. We put this answer, which was this part right here, and this answer, which was this little part right here on the graph, and we put them together. Now notice the gray part is going out towards -infinity, and the black part is going out to positive infinity. So it's going from -infinity to positive infinity. Okay, so really what our graph is, and let me erase this a little bit. Really, it's the entire number line. Okay, so how we write that in set builder notation, we say that x such that x is all real numbers. And for the interval notation, it goes from -infinity to infinity. Okay, so let's look at this one. 10 greater than or equal to 7 plus 3. Okay, now we're looking at an and. 9 minus 4x less than or equal to 1. And I'm going to subtract 7 from both sides. So 3 greater than or equal to 3x, divide by 3. So 1 greater than or equal to x, and I'm going to switch that x, just so I have my x first, then my inequality, then my number. And the little part is facing towards x, little part face towards x, and equal in 1. Okay, I'm going to subtract 9, -4x, less than or equal to, that would be -8, divide by a -4. So x will be now greater than or equal to a positive, looks like 2. Okay, so on our line graph, we've got 0, we've got 1, and we've got 2. Let me space it out a little bit more. Okay, for this one, we're going to have a closed circle on 1, and then we're going to go this direction. And then for this one right here, we're going to have a closed circle on 2, and we're going to go this direction right here. Now remember, and is talking about an intersection, so where they cross each other. Okay, now in our graph, we don't have anything crossing or overlapping here. We've got a starting point and then going one way, and then another starting point and going an opposite way. So there's no overlap here, which means if there's no overlap, and that's what we're trying to find, then that means that there's no solution because there's no overlap, because we are dealing with an and inequality.